Imagine lying on your back under a vast, star-filled sky. The air is cool and still, and the darkness is profound. Suddenly, a streak of light races across the sky, disappearing as quickly as it appeared. You've just witnessed a meteor, often called a shooting star. These fleeting, mesmerizing events have captured the human imagination for millennia, inspiring myths, legends, and even scientific inquiry. But what exactly is a shooting star? Despite the name, it's not a star at all. Meteors are actually small particles from space that enter Earth's atmosphere and burn up, creating the bright streaks of light we see from the ground. These tiny particles, no larger than a grain of sand, travel at incredible speeds, often tens of thousands of miles per hour. When they encounter the Earth's atmosphere, the friction generates immense heat, causing the particles to incandesce and produce the dazzling display we observe. For ancient civilizations, these shooting stars were often seen as omens or messages from the gods. In some cultures, they were thought to be souls ascending to the heavens or divine beings passing through the sky. Today, we understand them as natural phenomena, but the wonder and awe they inspire remain just as powerful. The sight of a meteor streaking across the night sky reminds us of the vastness of the universe and our small place within it. Chapter 2. The Origin of Meteors. To truly understand meteors, we need to travel back in time to the birth of our solar system, around 4.6 billion years ago. The sun, planets, moons, and other celestial bodies formed from a massive cloud of gas and dust that collapsed under its own gravity. As the sun ignited at the center of this cloud, the remaining material began to coalesce into smaller bodies, some of which became planets, while others remained as asteroids and comets. Asteroids are rocky remnants from the early solar system, while comets are composed mostly of ice, dust, and organic compounds. Both asteroids and comets orbit the sun, and over billions of years, their surfaces have been battered by collisions, causing them to break apart and scatter debris throughout the solar system. Comets, in particular, play a significant role in the creation of meteors. As a comet approaches the sun, its icy surface begins to vaporize, releasing gas and dust. This material forms a glowing coma around the comet and a long tail that stretches away from the sun. As the comet continues its journey around the sun, it leaves behind a trail of debris along its orbit. This debris, composed of tiny particles of rock and dust, continues to orbit the sun in the same path as the parent comet. These particles are what we call meteoroids, and they are the raw material for meteors. When Earth crosses one of these debris trails during its orbit around the sun, the meteoroids are pulled into our atmosphere, where they burn up and create the spectacular light show we know as a meteor shower. Asteroids, though not as visually dramatic as comets, also contribute to the meteoroid population. When asteroids collide with each other or with other celestial bodies, they can break apart, creating fragments that eventually become meteoroids. Some of these fragments are small enough to enter Earth's atmosphere, where they become meteors. Larger fragments may survive their journey through the atmosphere and reach the ground as meteorites. Chapter 3. Earth's Encounter. As Earth makes its annual journey around the sun, it sometimes passes through these debris trails left by comets and asteroids. When this happens, the meteoroids within the trail are pulled into Earth's gravitational field and enter the atmosphere at incredible speeds, sometimes exceeding 40,000 miles per hour. As these meteoroids plummet through the atmosphere, they encounter resistance from the air. This resistance causes the meteoroids to slow down, but it also generates intense friction, heating them to temperatures of up to 3,000 degrees Fahrenheit. At these temperatures, the meteoroids begin to vaporize, and the gases they release glow brightly, creating the streak of light we see as a meteor. The meteors we observe during a meteor shower are usually quite small, often no larger than a grain of sand. Despite their size, the speed at which they enter the atmosphere makes their impact dramatic. The bright streaks they produce can vary in color, depending on the composition of the meteoroid. For example, meteors rich in iron may appear orange or yellow, while those containing magnesium might glow green. Meteor showers occur when Earth passes through particularly dense regions of a debris trail. During these showers, dozens or even hundreds of meteors can be seen per hour, creating a dazzling celestial display. The frequency and intensity of meteor showers can vary depending on the density of the debris trail and the timing of Earth's passage through it. Each meteor shower has its own unique characteristics, determined by the parent body that created the debris trail and the specific conditions of Earth's encounter with that trail. Some meteor showers produce bright, fast-moving meteors, while others create slower, more subdued streaks of light. Regardless of the specifics, all meteor showers offer a chance to witness one of nature's most beautiful and awe-inspiring events. Chapter 4. The Radiant Point. When you watch a meteor shower, you might notice that all the meteors seem to originate from a single point in the sky. This point is known as the radiant. But what exactly is the radiant, and why do meteors appear to come from it? The radiant is an effect of perspective. Imagine driving through a snowstorm. The snowflakes seem to come from a single point ahead of you, even though they're actually falling all around. Similarly, as Earth moves through the debris trail left by a comet or asteroid, the meteoroids enter the atmosphere in parallel paths. However, because of the vast distances involved, they seem to converge on a single point in the sky when viewed from the ground. The position of the radiant is determined by the direction of Earth's movement through space relative to the debris trail. This is why different meteor showers have different radiant points. For example, the Perseids meteor shower, one of the most famous annual showers, has its radiant in the constellation Perseids, while the Leonids appear to radiate from the constellation Leo. Understanding the radiant is not just about pinpointing where to look in the sky. It also gives us insight into the path of the debris trail and the origins of the meteoroids themselves. By studying the radiant, scientists can trace meteor showers back to their parent bodies, whether they be comets or asteroids. Chapter 5: Types of Meteor Showers. Not all meteor showers are created equal. Some are spectacular, filling the sky with bright, fast-moving meteors, while others are more subdued, offering a more sporadic display. The differences between these showers can often be traced back to the characteristics of their parent bodies and the density of the debris trails they leave behind. Let's explore some of the most famous annual meteor showers. The Perseids. Occurring every August, the Perseids are perhaps the most well-known meteor shower, famed for their bright, fast meteors. The Perseids are associated with the comet Swift-Tuttle, which leaves a dense trail of debris in its wake. At its peak, the Perseids can produce over 100 meteors per hour, making it a favorite for stargazers. The Leonids. Known for their intensity, the Leonids can produce meteor storms with thousands of meteors per hour when Earth passes through particularly dense parts of the debris trail. The Leonids are linked to the comet Tempel-Tuttle and are typically active in November. During a meteor storm, the sky can become a spectacular display of celestial fireworks. The Geminids. Unlike the Perseids and Leonids, the Geminids are associated with an asteroid, 3,200 Phaethon, rather than a comet. The Geminids occur in December and are known for their bright, slow-moving meteors that can often appear in a variety of colors. The Geminids are considered one of the most reliable and impressive meteor showers, offering a steady stream of meteors over several nights. Each meteor shower has its unique characteristics, influenced by the composition and trajectory of its parent body, the density of the debris trail, and the timing of Earth's encounter with that trail. Some showers, like the Quadrantids in January, are brief but intense, while others, like the Meteorites in October and November, are more prolonged but less dramatic. Chapter 6: The Science Behind the Spectacle. Now that we understand the origins and timing of meteor showers, let's delve into the science that gives each meteor its distinctive appearance. The color and brightness of a meteor depend on several factors, including the composition of the meteoroid, its size, and the speed at which it enters Earth's atmosphere. Different elements vaporize at different temperatures, producing different colors as they burn. For example, meteors rich in sodium often appear yellow, while those containing magnesium can glow with a greenish hue. Similarly, iron can produce a bright yellow or orange light, while calcium might appear bluish. The size of the meteoroid also plays a role in the brightness of the meteor. While most meteoroids are tiny, even a few millimeters across, larger fragments can produce particularly bright meteors known as fireballs. Fireballs can be so bright that they outshine all other celestial objects in the sky, even the moon. Occasionally, these larger meteoroids may survive their fiery journey through the atmosphere and land on Earth as meteorites. In rare cases, a particularly large and fast-moving meteoroid can produce a bolide, an extremely bright fireball that explodes in the atmosphere with a loud sonic boom. These events can be startling and have been known to cause damage on the ground, as was the case with the Chelyabinsk meteor in 2013, which exploded over Russia with the force of a nuclear bomb, damaging buildings and injuring over 1,000 people. The science behind meteors is not just about their composition or appearance. It also offers a window into the early solar system. Many of the meteoroids that enter Earth's atmosphere are remnants from the formation of the planets, preserved in the cold depths of space for billions of years. By studying meteorites, fragments that reach the ground, scientists can learn about the conditions that existed in the early solar system and gain insights into the processes that shaped our planet. Chapter 7: Finding the Right Spot. Watching a meteor shower is one of the most accessible and rewarding astronomical experiences. You don't need expensive equipment or specialized knowledge, just a clear night and a bit of patience. But to get the most out of a meteor shower, it's essential to find the right viewing location. The best places to watch meteor showers are dark sky locations, far from the bright lights of cities and towns. Light pollution can significantly reduce the number of meteors you can see, so it's worth making the effort to travel to a location where the sky is truly dark. National parks, rural areas, and remote beaches are often excellent choices. Once you've found your spot, give your eyes time to adjust to the darkness. It can take 20 to 30 minutes for your eyes to become fully accustomed to the low light, allowing you to see even faint meteors that you might otherwise miss. Be patient. Meteor watching can be a waiting game, but the payoff is well worth it when you catch that perfect streak of light. Chapter 8: Essential Gear. One of the great things about watching meteor showers is that you don't need any special equipment. Unlike other forms of stargazing, where telescopes or binoculars are essential, meteor watching is best done with the naked eye. This allows you to take in as much of the sky as possible, increasing your chances of spotting meteors. However, there are a few items that can enhance your experience. A comfortable chair or blanket will make it easier to settle in for a long viewing session, especially if the meteor shower is expected to last several hours. Warm clothing is also important, as even summer nights can get chilly when you're sitting still for extended periods. A stargazing app on your smartphone can help you locate the radiant point of the meteor shower and identify constellations in the night sky. These apps use your phone's GPS and sensors to provide a real-time map of the sky, making it easy to find your way around the stars. Remember, meteor showers are a natural phenomenon, so there's no guarantee that you'll see a specific number of meteors. The best approach is to relax, enjoy the experience, and let the meteors come to you. Chapter 9: The Wonder of the Cosmos. As you watch a meteor shower, it's easy to be captivated by the beauty and mystery of the night sky. Each meteor is a fleeting reminder of the vastness of the universe and our place within it. These cosmic visitors, often no larger than a grain of sand, have traveled millions of miles through space before burning up in our atmosphere. In that brief moment of light, we are connected to the cosmos in a way that is both humbling and awe-inspiring. Meteor showers offer a unique opportunity to experience the wonder of the universe firsthand. They remind us that Earth is not an isolated planet, but part of a dynamic and ever-changing solar system. The particles that create meteors are remnants of ancient comets and asteroids, preserved for billions of years in the cold reaches of space. By watching a meteor shower, we are witnessing the ongoing story of our solar system, one that has been unfolding for billions of years. So the next time you see a meteor streak across the sky, take a moment to appreciate the cosmic journey that brought it here. Whether you're an experienced stargazer or simply someone who enjoys looking up at the night sky, meteor showers are a reminder of the beauty and mystery that surrounds us. As we conclude this journey through the world of meteors and meteor showers, I encourage you to take some time to experience these celestial events for yourself. Whether you're watching the Perseids in August, the Geminids in December, or any of the other meteor showers throughout the year, each one offers a chance to connect with the universe in a meaningful way. Consider supporting organizations and initiatives that promote dark sky preservation, so that future generations can continue to enjoy the beauty of the night sky. And remember, the cosmos is always putting on a show, you just need to look up. Thank you for joining me in exploring the wonders of meteor showers and meteors. If you enjoyed this video, please like, share, and subscribe for more content on the fascinating and ever-changing universe around us. Keep your eyes on the skies and happy stargazing.